Hello guys, today I want to answer specific questions. Why the result of an exponential functions cannot be negative? Uh, Most of the time students are asking these questions. Why they can have the value of y, that means the range. eh? Why this value cannot be negatives? Uh, we have here three exponential functions. As we can see, the exponential functions have some similarity with exponent that you already saw when you were in high school, where there is a base and there is a power. So that's why some property of exponent, we're gonna use them also when we're gonna deal with exponential value. Let's remember, mainly when we talk about exponential, we mainly deal with this exponential where the base is the number e. This number is approximately 2.7182. This number was found by Euler, is an irrational number. We mainly use this base, but for exponential functions we can have different value for the base. So before answer this question, why the result, the y cannot be negative, we're gonna make a review about some property of exponent, because we say there are some similarity between exponential function and exponent. Let's review them. You remember those property when you were in high school? If you were x to the power n times x to the power of p, we just make the additions. This property also I highlight in red. It's really important since we'll use it to understand why the result cannot be negative. When you have a power, when the power is negative, the result can be written like 1 over x to the power of n positive. That's very important to remember since we will use this property also. Those property are the property of exponent. We use them also when we are dealing with exponential values, since exponential functions is a kind of there is some similarity of them. Why? Try to understand. We have like here 2 to the power of x. This is an exponential functions, but for an exponent it will be like that: fx equal x to the power of 2. For here we have the variable x, which is the base, but for the exponential functions the variable is not the base, the variable is the exponent. Okay, now let's try to plug some value for x and find some value of y, and we're gonna understand. Okay, we have these exponential functions. f of x equal 2 to the power of x. We can have other exponential, we just choose one. We're gonna choose different to see the difference. I just choose one. Okay, I put 1 for x. When I have 1 for x, I have fx, that's the y value, the range is gonna be 2 to the power of 1. That's gonna give us 2. I put 2 for x. I'm gonna have 2 to the power of 2. That's gonna give me 4. When I put 3, give me 3 to the power of 3. That's gonna give me 8. So we understand easily, for a positive value of x for these exponential functions, I have a positive value here. What about when x is negative? If I have -1, I'm gonna have 2 to the power of -1. That's why we're gonna use this. Remember this property? This property, we're gonna use this property. When you have a power negative, we can write different. We can write it differently, like 1 over x to the power 1 over x to the power of n. So that's what we're gonna do here. I got 2 to the power of -1 is gonna written like 1 over 2 to the power of 1. That give me 1 over 2, 1/2. That's the value is 0.5. The same also if I have 2. Follow me. If I have 2, I'm gonna write it like that. For -2 is gonna be equal to 1 over 2 to the power of 2. Okay, right? This is gonna be give me 1 over 4. 1 over 4 is 0.25. So we see, if we keep getting some value minus 3, the result always gonna be positive, you know, even though those value gonna be 0 point something. They're gonna be between 0 and 1. Okay, let's say we have x equals 0. What we're gonna have if x equals 0, f0, what we're gonna have 1. No, we're gonna have 2 to the power of 0. 2 to the power of 0. Remember, when you are at school, whatever the number to the power of 0, this number is 1. Whatever the number, that's an absolute value. Whatever the number to the power of 0, the result is gonna be 1. So we see for these exponential functions, whatever the value I took, whether it's positive, whether it's negative, I end up with a positive value. That means the range, the results, the y value are gonna always be positive. So that's an example of an exponential functions. But you can say, what if I have another exponential function where the base, let's say if I have an exponential function, let me take another one. Let's say I have an exponential function where the base, let's say I have fx. I'm gonna change the base. Since an exponential function, the base can be any number. Watch for the base can be any positive number. We'll end this. Let's say if I have not any number, the base, let's say I have f of x equal 2 to the power of x. Let's say here the same one. Let's say if I took a negative value, minus 2 for x. This is what I'm gonna have for f of x. What I'm gonna have 3 to the power of minus 2. So remember this property of any exponent, that's gonna be 1 over 3 to the power of 2, which would give me 1 over 9. This will give me a positive value. So as we can see, for different exponent, mainly this exponent you deal most of the time with it, e to the power of x. Okay, remember e is a number between, like we said before, is a number of Euler. This number is between it's 2.7182. That's the number. So for this number, that's gonna be the same. If we have e to the power of minus 1, we will do the same thing. So either x negative, positive, 0, the value gonna always be positive. So there is one case that we have to understand. What if I have an exponential function like that? F of x equal, let's say I took a number, whatever the number, I took minus 3 to the power, remember the base is a number, of x. What about these exponential functions? If this is an exponential function, in this case, let's see. In this case, what are we gonna have? If we have x equal 1, we're gonna have f of x. What is it gonna be? I'm gonna have minus 3 to the power of 1. That's gonna give me minus 2. Wow. So an exponential, the one can be negative? No. Why no? Because there is a rule. They say the base cannot be negative for an exponential. I repeat again, the base should not be negative. Whatever the exponential functions, the base cannot be negative. There is three conditions. The base cannot be negative, the base cannot be 1, the base cannot be 0. So the base can be any positive value that is not 1, not 0. So The base for any exponential functions, it's a positive number, exclude 0 and 1. That's the principle to be an exponential value. With these conditions, we can be sure whatever the number, whatever the base, not whatever a positive base, the result, what I call the range, gonna always be positive. That's the conditions. For an exponential, I repeat, the base cannot be negative, the base cannot be 1, the base cannot be 0. That's principle for any exponential function. I will explain in another video why the base cannot be negative and why the base cannot be 1 and 0. I will explain that in another video. But now keep in mind, when we talk about exponential value, we always deal with those functions. Let's say 2 over x, 3 over x, 5, whatever the positive value over x, e over x. Remember, e is a number. Okay, those are different kind of exponential function. That means the power, which is the variable, can take any value, but the base should be always a positive number. The base cannot be 1 and cannot be 0. Okay, so remember, we use simple exponential functions, but you know, we can have this as an exponential function. We still, the variable can, there is no condition for the exponent. I can have f of x equal to the power of x plus 1. Still, this power is a variable. We know these expressions is a variable. Okay, I can have fx equal, the principle, the base should be a positive number. I don't care about the exponents. I can have f of x equal e to the power of 3 times x, whatever the expressions, 3 times x plus whatever. So the power is still a variable. This is an expressions. This is vary up to the value of x. Okay, that's an exponential. But remember, the base is always a positive number. So we understand whatever the value we end up with the exponent, either positive or negative number, the range, that means the result, the y value, always going to be positive. I hope that you understand why the result, the range of any exponential value cannot be negative. For another video, I will explain why they put these conditions that for an exponential functions, the range, the base should be positive. I will explain why they put this condition. But right now, I understand the base cannot be negative. So see you for another video. If you like this one, subscribe to my channel.